Hello, this is your question for on November 2020 paper, the mechanics paper from Edexcel. You have a ladder AB, so all these. The end A of the ladder is on a rough horizontal ground. The ladder rests against a fixed, smooth horizontal grain at point C. We know some distances. The ladder is inclined at an angle alpha. We know the sign, which means we know the angle. Coefficient of friction is mu. Ladder rests in limiting equilibrium, which is going to be the case in all your questions. Is modeled as an uniform rod, which means we can draw the weight in the midpoint. Using the model, we have to find the magnitude of the force at C. They give us a value and we have to deduce it. So first of all, let's going to draw all the forces that are acting. So the mass is M, so I'm going to draw in the midpoint of the ladder the weight of the ladder, which is M multiplied by gravity, mg. And at A, I have friction. The friction is going to go against the direction of the motion, or the intention of motion, so the tendency. So this ladder will slip down if I don't have friction, so the friction is stopping the ladder to slip down, so it goes in this direction. I'm going to write FR from friction. I will have a normal reaction. I'm going to call it RA, and at C I will have a normal reaction perpendicular to the peg or the bar that I have here, so perpendicular to this. I'm going to call it RA. It's RC, sorry. It's smooth, so I don't have friction here. And this is the force that they are mentioning, and I don't have any other forces acting on the ladder. So I need to find this force. It's in equilibrium, which means two things. One is the resultant force is zero in any direction, and the other is that moments about any point is zero. I can use either or both for the question. So if I find the resultant force, in the vertical direction, I'm missing 2, and in the horizontal direction, I'm missing another 2. So it's not going to be helpful. What I can do is to take moments. And if you think a tiny bit about where to take moments about, you will see that taking moments about A is going to help you, because RA and F are not going to produce moments about A because the distance is 0. So I'm going to have only this one and this one in my equation. So let's going to take moments about A. We are going to make that equal to 0. So moments about A must be 0. So the clockwise moment is going to be equal to the anti-clockwise moment. So about A, if I take moments about A here, this one is producing an anti-clockwise moment. So this one is going to be anti-clockwise. And this one about A is going to be clockwise. So I'm going to make them equal to each other. The first one is going to be force times perpendicular distance. So from A perpendicular to the line of the force, we are talking about this distance here. So this is the line of the force. And the distance that we need is this distance here, perpendicular from the point to the line of the force. This distance is going to be, so this is 3A because it's half of the rod, 3A, and this is alpha. This is the hypotenuse, which means this side, which is adjacent, is going to be hypotenuse times cos. So this side is going to be 3A cos alpha. So the moment is going to be the force, mg, times perpendicular distance, which is 3A, so 3A times cos alpha. This is going to be equal to the moment that this one produced, the anti-clockwise moment. So it's the force times perpendicular distance, so from the point to the line of the force. Again, this is the line of the force. So my perpendicular distance in this case is going to be this one, so this is perpendicular here. And this is, we have to find it, because we know alpha, and we know this is 4A, and this is the hypotenuse. So sine alpha if we write here, sine alpha is going to be, just considering the small triangle, not the whole thing, is going to be 4a divided by what I need. Yeah, so 4a divided by what I need. And I know sine alpha is 4/5. They give it to me, yeah? So it's here, 4/5. So I know that x is going to be 4a divided by 4/5. So it's going to be 5a. Sorry, 5a. So this distance here is 5a. So the moment is going to be RC times 5a. And this is going to be RC times 5a. And we can write cos alpha, because if we know sine, we can find cos easily. So you have to think that you have a triangle, and I think that's the easiest way and fastest way of finding. So if this is your angle, if sine is 4/5, that means that 4 is the opposite, 5 is the hypotenuse. Using Pythagoras, you know this is 3, which means the cos is going to be 3/5. Yeah, so this value here is 3/5. I can cancel a, and I have mg times 3 times 3/5 is going to be RC times 5, which means that RC is going to be just 3 times 3, 9 mg, divided by 5 times 5. And that's what we had to prove. Yeah, that's the first part. Now the second part is a hence. So we are going to use this information, or otherwise find the value of mu. So the coefficient of friction here. The coefficient of friction, remember when it's in limiting equilibrium, we know that the friction is that coefficient of friction times the normal reaction at that point. Yeah, so we are going to find the coefficient of friction divided the friction and the normal reaction at that point. So let's going to see how we find them. To find the friction is this horizontal force. What I can do is to make use this resultant force in the horizontal direction. So the only horizontal forces that I have is the friction pointing that way and the component of this one pointing that way. Yeah, so I'm going to use a different color. So you have this resultant force. If we resolve forces, we'll have one horizontal component and one vertical component. Yeah, what we need to know is what happens with these angles. This angle is alpha. These are alternate angles, these ones, which means this is alpha as well. And this is 90 minus alpha, because I have a right angle triangle here, or right angle, yeah? So this is 90 minus alpha, which means this is alpha, yeah? Because again, this is 90. So I can say that this angle here is going to be alpha. So this component here is going to be RC. This is the opposite. Yeah, if you see this triangle, which is right angle triangle, this is the opposite, so it's sine. So this component here is RC sine alpha. And the vertical one, and we are going to use it in a minute, is going to be the adjacent to the angle. So it's going to be RC cos alpha. RC cos alpha, and we know sine alpha and cos alpha, so that's what I'm going to use. So if I resolve forces horizontally, Fr is going to be equal to this force, yeah, my only two horizontal forces. So friction is going to be Rc, we said sine alpha, yeah, sine alpha, Rc sine alpha. Rc was 9 mg divided by 25, and times sine alpha, that was 4/5. So the friction is going to be 36 mg divided by 125. Now I can find Ra doing the same but in the vertical direction. So forces pointing up, this one and this one together, is going to be both together are going to be the same that this one pointing down. Yeah, so my resultant force is 0. So I have Ra as Rc cos, Ra plus RC cos alpha is going to be equal to the force pointing down, which is the weight. So RA is the one that I need for finding the friction coefficient. It's going to be mg minus RC, again, is 9mg divided by 25, and cos alpha was 3/5, yeah? Just looking at the triangle, 3/5. So this is 98 over 128, so 25 mg, yeah? So the coefficient of friction, coming back here, we are going to do that. Coefficient of friction is the friction, which is 36 mg divided by 125, divided by the reaction at A. And we can cancel mg, and when we divide, we have 0.367, something else. They don't ask us to round, no. So I'm going to leave to two significant figures, for example, 0.37. Yeah. And that's all with this exam question.